Hello, everyone. My name is Brianna Stanley, and I am a fifth year graduate student at the Virginia Institute of Marine Science. And I'm excited to share with you today my Virginia Sea lesson plan, Dial C for Collaboration. So, as a graduate student, I am interested in studying nitrogen. The part about nitrogen that I'm interested in is how different forms of nitrogen can act as a food source for the phytoplankton and bacteria living in coastal environments. Now, studying nitrogen is a bit of a niche interest, but I've actually been interested in nitrogen since I was a sophomore in high school. I started learning about fertilizer runoff and was completely hooked on studying nutrient pollution. And my Virginia Sea lesson plan today will be using some of the skills that I use in the lab to present a graphing exercise for students. So in my lesson plan, students will graph in Excel or Google Sheets, depending on what you have access to, interact with the y equals mx plus b equation, and collaborate with each other to compare results. So as I mentioned, this lesson plan is based off of data from my own research, specifically how to measure ammonium, which is a type of nitrogen found in water. And how we measure ammonium, which we can't see, is by converting it to this other compound that is visibly blue, and then measuring the absorbance of that blue compound on a UV spectrophotometer. Now, in order to measure ammonium, which we don't know what the background concentration is we create a set of standards that we do know how much ammonium is in and use that to create a standard curve. So this curve can then be graphed. This data can then be graphed to create a curve that we can then use to calculate our unknowns with based on what we measure on the spectrophotometer. And this lesson plan actually has students graph data from my own standard curves from my own research. There is background in the teacher handout about running ammonium and why ammonium is important. However, in the actual handout, I've left the graphs a bit more vague. So the x-axis is known concentration rather than ammonium concentration, and the y-axis says reading or measurement. And I did this so that you can take my lesson plan and readapt it to, say, a different environmental parameter or something else that you're learning in class. And so the first part of my lesson plan includes graphing and calculations. There's a tutorial for both Excel and Google Sheets that students can use. Once they graph their standard curve data, they'll go through a stepwise worksheet to calculate their unknown samples concentration. The second part of this activity is collaboration. So students are actually going to get the same unknown sample value, but the data they're going to get is from actually 3 different standard curve runs that I did, and they're all slightly different. So this is a great opportunity for students to work together and compare their results and to go through the steps of verifying if they're correct like a scientist would. I hope you enjoy my lesson plan.